Okay, thank you very much for waiting on till the graveyard shift. Since I know about half of you in the audience, we could probably have done this somewhere else, but I'll run through the slides, and I presume they'll be available afterwards. I know the video will go up afterwards as well. So, my name is John Cosgrove. I'm a section head of electrical engineering at the Limerick Institute of Technology, and for my sins, I also run a research centre called Acorn, the Acorn Research Centre in LIT. And we primarily work on innovation with industry, so whatever industrial solutions are needed, particularly in manufacturing space, in industrial automation, and more recently, in recent years, in energy. I've been, for the last 3 years, the principal investigator on a project called Tempo, which is Total Energy for Manufacturing Operations. A large project, the largest nationally funded project in energy efficiency in Ireland. It's been a very interesting project. We've worked in very close collaboration with a number of the leading multinationals in the country. It was funded through the IERC and through Enterprise Ireland. So I'm going to give some quick outputs from some of the work we did today and explain a bit of the project as we go along. And as I said, I'll run fairly quickly through this and take any questions at the end. And hopefully I can work this Mac. Okay, so I'll skip the lecture here, which is that energy efficiency in industry is not that complicated. You either turn things off or you turn them down. There isn't really a lot of other things that you need to concern yourself with. So I have essentially my key points, what I've extracted from nearly 4 years now of working with both large companies and with smaller manufacturing SMEs on energy efficiency, is that there is really a set of essential steps that you can follow through. And if you look down through that list, you'll see that renewable energy and heat exchangers and complicated things like that are actually at the very end of the list. There's a huge amount of savings still to be achieved in industry just by knowing where your energy is used, when it's used, and why you use it. And that gives you opportunities for optimization that can save 20%, 30%, 40% of your electricity consumption. And most plants, we can easily achieve those kind of savings or point out to the client company where the savings can be achieved. So a typical profile of an Irish manufacturing plant, the red patterns there are essentially the weekly electricity consumption over a year. You can see two differences in that. One is the summer shutdown period and the other one is Christmas. But the thing I like about this graph is that it is the same the whole way year round. So weather has no bearing on energy consumption. Changes in volume of production doesn't even necessarily have a big bearing on electricity consumption. But the interesting part in this slide, and I generally like to walk around and talk, but is this bit here. Okay. This bit represents the amount of electricity that's being consumed no matter what is happening. If there's nobody in the factory, it's still consuming a third of the power needed for when it's in full production. And that figure can be even higher in some factories. So we're consuming in the factories 24/7, huge amount of electricity, and in many cases, production during, say, weekend times or nighttime might be non-existent, and therefore there's opportunities for savings. But this is a very, very typical profile of an Irish manufacturing plant. There is a large base load of power consumption going on all the time, okay? And that's your key opportunity for energy saving or energy reduction. So we were tasked by industry to look at, and kind of going back a little bit of time, a lot of manufacturing companies who had addressed sustainability and green targets and reductions in energy efficiency would have implemented CHP plants, would have done energy audits, would have done LED lighting and various initiatives, but primarily on the facilities side. And there's sort of a big black box of what is production, and the facilities people generally not allowed anywhere near our nice production areas, usually for good reason. So the focus had been primarily on the facility side. In the typical large manufacturing plants in Ireland, production consumes around 60%, 55, 60% of the electricity consumption. So 40% in facilities, 60% in production. But all the initiatives over the last few years have primarily been addressed at the facility side. And production was the great unknown. So the task from industry was, could we come up with a methodology, an approach, a set of tools that would help people track their energy use in production? So we can say we did that. And we've piloted that in a couple of plants, and we've shown very good results. But it is a research project; it's not a commercial output at this point in time. Maybe in the future. So one of our primary case studies, a large medical devices company, Depuy Synth in Cork, a company who would have a very good reputation for their engagement with energy projects, have a nice wind turbine currently over their factory, supplying about half their electricity. So very engaged in the engineering, in the green process, if you like, in savings to energy and in the sustainability agenda. And as a plant, the graph of electricity use there shows about 25% of their electricity is consumed at weekends. But production is typically about 5 or 6% at weekends. So everything is left on all of the time in production. Okay? So the approach we took was, and they knew this, when we started with them, they knew this. Okay? It didn't take us to go in and tell them that. And that's often the case. Companies know where energy is being wasted in their plant. They knew this, but they couldn't drill below that. They couldn't drill below the high level analysis to see where was it being used, where was that electricity being used, and could it be changed? Could things be turned off? Could things be turned down? So our approach was to take a lean value stream mapping approach, to map out as the product as it goes through the factory, through the different value streams, and to associate the energy consumption that goes with that product at every stage in the process. Okay? And to roll that information up essentially to see what your entire value stream is doing, and to roll up all your value streams to see what your entire production is doing. Okay? And then you still have your other facilities energy, so we apportion a cost of that to the value streams. So the goal was to take the cost of energy consumption that's used in production and charge it as a cost to the people responsible for it, the production personnel, the value stream managers, to make them responsible for the use of energy, to give it to them as a controllable cost. Okay? At present, in the vast majority of factories that I've dealt with, and over the course of this project, it's been very nice. I've been in over 50 industrial sites in Ireland and abroad over the last 4 years. I haven't yet seen a factory where the costs are apportioned down to the people who incur the waste of electricity or incur the electricity use. So essentially, it's not a novel idea. This is not something that it was an approach that maybe hadn't been tried at large scale before. The other key to the approach was, these are complicated factories. These are large factories. The Depuy has 188 production machines. Their one value stream is making about 2.5 million parts per year. You know, hundreds of product families within that. So it's not a simple task. But by taking the product view, we were able to utilize their production information. So their production database systems, they have tags and scanning systems tracking where products are going through the factory. We didn't put metering in any of the production machines. We did temporary metering. We went in for a couple of days. We profiled machines. We took extracted data from them. We built profiles or models of the production equipment. And you know, in one case, they've 18 grinders. We didn't do that 18 times. We did it once. Okay, so we know we've incurred errors in that. But there is no cost of sub-metering to get this information from the factory. And we've reasonable estimates, okay? We ran the model for a number of months. We were over 90% accurate. In terms of managing energy, you know, big chunks of energy in your factory, more than 90% accurate is more than enough, okay? To identify where there are significant savings opportunities. So the approach was not to have any metering. The approach was to use existing data in the factory, information that's already in databases, in OEE systems, in OMS and manufacturing tracking systems, but also from PLCs and variable speed drives and other intelligent systems that might be in the factory. And in some cases we did recommend, and we did develop a monitoring solution, in some cases for a particular significant energy user, something consuming 10% or 15% of the consumption in the production line, we might recommend that it warrants having a meter put on. And those were the challenges that the industry gave us. There's a lot of busy stuff on that graph. We had a dashboard on our database as an output. This is not cloud-based. This is something that lives within the factory on a server sitting there. It's quite a fairly simple MSQL database. And the graphics, we never tried to develop very fancy graphics from this. The dashboard is similar to most dashboards you find in industry with dials and charts. I think the difference with what we did do is we built a hierarchy because we came from the product up. Okay, either in discrete units or in kilograms of liquid or of steel. By building it from the product up, we have a hierarchy of the products, the processes, the value streams, and up to the factory. So we can roll up all of the KPIs in terms of waste energy and useful energy all the way up to the factory level. and you can drill up and down through that. So you can see where particular KPIs move out of trend, move against target, and you can drill down to that. So for the production manager, they can clearly see where is the largest consumer of energy that's costing me the most money that I might be able to do something about. And if I do something about it, the following month they can see the data updating, or the following day actually they can see the data updating to show that they have made some savings. Okay? As I said, we piloted in Dupuy. We also did a pilot in GlasgowSmithKline, in Cork around a different production process. In both cases, we've identified significant savings from it. Okay? In Dupuy, on one production line, it's around 60,000 euros savings per quarter. In GlasgowSmithKline, it's around savings of 100,000 euros for 1 year. Through investment, through changes with very little cost. Primarily behavioural change, changes in operational practice, okay, retraining of staff and putting in place new steps or removing steps from the process. But the results have been very good, and the companies have been very pleased. I'm not a Mac fan. Okay, I think I got that wrong. But the last thing on Dupuy, it was essentially the win for us was from the production manager's kind of final comment to us was it was his last uncontrolled cost. He was paying a charge, an overhead to the business of around 7% as a fixed cost every quarter. Doesn't matter what he did. Every other cost in his business, personnel, resources, materials, he had teams of people chasing after 0.5%, 1/4% savings, quarter on quarter. But he could do absolutely nothing about his energy. Now he has a tool that shows him how much energy he's using, and he can actually dedicate some time and some resources, some manufacturing engineers, some energy engineers to make those changes happen. We were also asked towards the back end of the project to see if it was applicable to other smaller indigenous manufacturing SMEs in Ireland. And we worked particularly with an association called the PTMA, Precision Tool Manufacturing Association, with two of their companies, Takumi and Kroon Precision. So precision engineering companies with milling machines and lathes and kind of metal, I call them metal bashing processes, but they don't really like that. High precision metal bashing processes. So these would have much less significant electricity bills. Dupuy, before the wind turbine, would have been looking at 4 to 5 million euros a year, maybe 2 million after the wind turbine was installed. The indigenous SMEs, probably maybe 150,000 or 100,000 euros in electricity bill for a year. But the interesting thing was that they had a different ask. Their primary interest was in understanding how they could work out, quantify the cost of energy per product, which tied up with our kind of approach, but from the point of view of tendering business, because that's what they do. They tender primarily to the multinational sector to make specific parts, and they have to estimate, if I'm going to make 100,000 of those parts for you, I'm going to give you a price per part. And they had no benchmark, they had no measure for what the electricity or the energy cost overhead was on making that part. And if it turned out to be a product that took a lot of energy, they'd lose money on it. If it turned out to be a product that didn't use very much energy in a plastic or an aluminium, well, they've still had to put an overhead of electricity on it, and maybe their price would be too high, and they wouldn't get the business. So it was quite key to them was to actually understand what the cost of energy was per product, and we were able to do that for them in a very straightforward way. In the process of doing that, they also discovered that they could get very interesting production information from the energy monitoring, temporary energy monitoring that we put in place. And they were able to find lots of other kind of non-energy benefits from this. Okay, in Takumi, they discovered a fault in a machine because of the energy monitoring that we put in place. That machine is their highest value product is made on it. Their two highest trained operators work on it because it's forever going out of calibration. It has to be a lot of effort in setup time and everything every day. And essentially that was because of a fault that's been in the machine for nearly 18 months. Our monitoring solution found that fault. They tell us that that's worth more to their business than anything else we might do with it. It's worth more to their business than their electricity costs. So the non-value, just having somebody focus on production and look at it in terms of looking at it differently has provided a lot of useful stuff. But across their electricity consumption in total, this would be a company who work a typical 5-day shift, running overtime in the evenings, maybe, and some Saturday mornings. Not that dissimilar to a lot of companies. But essentially more than 40% of their electricity consumption is being consumed at a time when the plant is closed. And there's a number of savings we found across a few different things. They had 2 full compressors running all of the time with a backup standby one, a third smaller compressor, all 3 running all the time. They now have pretty much 1, and sometimes they're able to default down to the smaller backup compressor only for compressed air, because they had huge leaks. And just all these things were found very quickly. Our engagement with Takumi was a matter of 6 or 8 weeks. I think, they're not going to achieve 40% savings. It's going to take a little bit of time for them to change things. They have to change their electricity contract, and they've already done some of it. So about 10 or 12% of it is achieved almost immediately. And by year end, if they compare 2016 to 15, we expect more than a 20% saving in their electricity. Okay, so it's a significant, because that's money that can be reused to do other interesting things. Sorry, I got my companies. That was with Croom Precision Engineering. With Takumi, we did a very simple thing. We just logged their energy consumption over Christmas for 10 days while the plant was locked. I mean, gates were closed, lights were off, a few servers were running, but essentially no consumption. So €1,000 of electricity consumption over that time for no output in production. And that and other monitoring we did, about a 30% waste of electricity over a year. The other graph shows there essentially different profiles for milling different material in a mill, and from that they were able to cost down the exact price per kilogram of aluminium or kilogram of steel or kilogram of plastic for bidding for work. And they found that very useful. But we also continue to work with them on some specific machines. We're quite interested in operator engagement, bringing energy awareness to people in the factory, and in some of the larger companies we've run energy clinics where employees at a plant can book slots with an energy doctor and discuss whether it's their house or work or and we've tried a number of different things with companies. In Takumi we put what we call social feedback on the machine, so we put a screen beside the binning machine, and you can see the smiley faces there, or the cross face and the smiley face. And when the machine was running in an energy efficient way, so it was working and making product and adding value, there was a nice green face on it. But when the product finished and it was an end of a cycle and the machine was sitting in idle, once it was sitting more than a couple of minutes, it changed to an orange face, and then after a few more minutes it changed to a red face and stayed red. And these are nice big screens that you can see from the other end of the factory. So they discovered a number of things. Firstly, there was capacity to run a number of batches that they weren't aware of, because machines were sitting looking like they were doing something, but actually they were finished. Our system showed them they were finished. And it made the operators unload them faster, so they were actually getting more production, more productivity throughput. But the operators actually responded well to this, and the savings are about 10%. They have a step back position on the machines. When there wasn't going to be another batch for a while, they could press a button, then essentially the energy consumption fell from about 90% from the idle down to a very low level of just the machine being still alive. So they engaged with that over a couple of weeks, and we reduced the electricity consumption by those machines by about 10%, purely just by giving them feedback. Happy, not happy. Okay? But the operators were quite receptive to that, because it all contributes to saving money for the company. We did some further work, and this might be a bit detailed, but the bottom graph there essentially has 3 curves, and it's 3 weekends one after another. Okay? The first weekend, the first line at the top was before we did any training with the operators, and it just shows that production during the Friday drops on Saturday, but there still is a significant base load. Okay? The line below that, which is a green one, was after we did essentially what we call micro training, 10-minute training with each operator on each machine, explaining what they could do to step back the power consumption, what they could do to leave it and not to leave it in an idle state, essentially what they were empowered to do by the company. And we did that with the facilities manager. And at the following weekend then, it was about a 20% saving in that idle weekend energy consumption. And that actually ran on. That was Bank Holiday Monday, and so you can see the green line ran on. The third one was on the following weekend. The facilities manager took it on himself to go in on the Sunday night and hit the e-stop off on every single machine in the production area, and that dropped by another 20%. So they achieved a 20% saving, and they know they can achieve another 20% saving just by getting people to actually close the machines down properly on a Friday and start them up properly on a Monday morning. So they're quite enthused by that. So essentially the development, our tool and the monitoring solutions we developed through the project have enabled that. And that's all we've done. What we've done is provide knowledge to them that they can go and get savings. And I think by quantifying that very early on, we take a very rough estimate. We tell them, you can save 20%, show me your bills, you can save this amount of money, now go to the plant manager and tell them you can save it. Because we're very confident that we know we can deliver that. Okay? And we have a call out at the moment for some of the companies in that consortium for a follow-on project. So we have a number of them signed up, and we're planning to put it in as a cluster proposal with Enterprise Ireland, which will attract a certain amount of grant aid. And we're charging the companies a contribution of 2.5% of their electricity bill next year to be part of the project. Which will run for about a year. And then we will do this with all of these other companies. So we have Penn Engineering in Galway, and we have a Man Engineering company in Waterford, and we have a couple of others in the Limerick and Shannon region. But we're open to other companies who want to talk to us or who want to engage. And then for companies with a larger bill, we have follow-on projects with, we hope in the near future, with another large medical devices company. But we're always open to other clients. It's a research project, so it's not commercial thing. We're not selling it. Our goal would be to try and find a fit with the funding from an agency to do the development work. But it is particularly focused around improving production outputs, saving money within the production area, growing productivity, growing jobs, and that still fits with the Enterprise Ireland agenda. So I've probably taken a bit longer than I have, but okay, I'm on time. So that was me. Happy to take any questions or discussion, or take it afterward. I'll be around for a little while afterwards if anyone wants to talk to me. Okay, thank you.